Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today we continue to look at Pure Mathematics 2 and the topic number 1, algebraic methods. And we are in example 6. And I want to explain example 6 and its details and what it entails. On page 8, we are told that fully factorize 2x cubed plus x squared minus 18x minus 9. And the fact that we know this is our function, our fx is equals to 2x cubed plus x squared minus 18x minus 9. That is our function. When somebody tells you to factorize fully, they want you to first of all note the factor of this particular function, and you cannot know the factor if you do not know the if you don't know the approach. And of course, we've learned about the factor theorem. We need to continue to explain or to substitute, because on page 7 we are told substitute values into the functions until you find a value p such that gp is 0. Keep substituting values, and let's talk about p being equals to probably -1 or something. Let us have p is equals to -1. So f -1 is 2 -1 cubed plus -1 squared minus 18 -1 minus 9. What does this give us? This one gives us minus 2 plus 1, 4, 4 plus 18, 12 plus 18, 22, and I think the entire thing will give you 8. The entire thing will give you 8, because this is -1 minus 2 plus 1 minus 1 minus 1 plus 18 minus 17 minus 9 is 8, and this is not equals to 0, so we cannot say x minus 1 is therefore x minus -1, which is x plus 1 is not a factor. Please note that if x minus p is a factor, then fp is equals to 0. So let's take p to be equals to 1. What about f1? f1 is 2 1 cubed plus 1 squared minus 18 1 minus 9. If you evaluate all these, you will get -24, and therefore x minus 1 is not a factor. What about if we took p to be 2? So f2, we're going to have 2 cubed plus 2 squared minus 18, 2 minus 9, which definitely, if you work it correctly, is going to give you -25, and therefore x minus 2 is not a factor, because -25 is not 0. What about p is 3? f3, this is 3 cubed plus 3 squared minus 18, 3 minus 9. If you work out this correctly using your calculator, you'll find this is equals to 0. And then yes, x minus 3 is a factor, because we have fp is being equals to 0. Therefore, if it is a factor, then we are supposed to divide confidently, knowing that we are going to have a remainder of 0. That means 2x cubed plus x squared minus 18x minus 9 divided by x minus 3. This is 2x squared, 2x cubed minus 6x squared. We're going to have 7x squared. You drop minus 18x divided by x. You have plus 7x, 7x squared, 7x squared minus 21. You get 3x. You drop 9 minus 9 divided by x. You have plus 3. 3x minus 9, and true to it, the remainder is 0. So, if you remember, the question was factorize the function fully. And we have now what we need to do. We have x minus 3 multiplied by 2x squared plus 7x plus 3 will obviously give us back the function. And because this one is linear, what we need to do is to deal with this and try to factorize it and see if we shall get linear function. Because factorizing, we are told to factorize fully. And of course, our B and AC, our B is 7 and AC is 6. Which two numbers do we multiply? They give us a 6, and we add, they give us a 7. Of course, 6 and 1. So we have this one being rewritten in terms of 2x squared plus x plus 6x plus 3. And we're talking about x is common, 2x plus 1 plus 3, 2x plus 1. 2x plus 1. So we have broken or replaced the middle term with the factor that we have realized, which is 1 times 6, and 1 plus 6 giving us 7. So 2x plus x plus 6x plus 3, factorize out two terms at a time, and we are having x plus 3, 2x plus 1. And of course, don't forget to include the first divisor, x minus 3. And we have fully factorized that particular expression. X minus 3, x plus 3, and 2x plus 1. That is exactly what was expected of us. Part B of the same question is asking us, hence, sketch the graph. Sketch y is equals 2x cubed, 2x cubed plus x squared minus 18x, of course, minus 9, or rather y is equals 2x cubed plus x squared minus 18x minus 9. Sketch this. And now that this one is just equals to x minus 3, x plus 3, 2x plus 1. And the critical values already can be seen. Critical values, x is equals to 3, x is equals to negative 3, and x is equals to negative a half, because all of them have to be, they have to make each of these brackets 0. So even if you were to sketch it up here, we're going to have something like this. There is a 3, there is a negative 3, there is a negative a half, and there's a positive 3. These are critical values, or where the graph cuts the x-axis. What we need to do is, as x approaches negative infinity, as x approaches negative infinity, and let's say as x approaches negative infinity, how does y behave? let's put negative 4 here. Negative 4 minus 3 is minus 7. This bracket gives you minus 7. This bracket gives you minus 1. This bracket gives you minus 8 plus 1, another negative. So y also approaches negative infinity as x approaches negative infinity. So as x approaches negative infinity, y approaches negative infinity. So it goes without saying, as x approaches positive infinity, how does y behave? Y, let's say 4. 4 minus 3 is 1, positive. 4 plus 3 is 7, positive. This is positive. Positive times positive times positive is a bigger positive number. So y also approaches positive infinity. So our graph simply talks of something like this. As x approaches positive infinity, y approaches also positive infinity. And that is the sketch of y is equals to fx. And that is just like it. So be on the lookout. It's quite an important question. Watch it again and again slowly, and you will find your way. All right.